This is a video on how to calculate concentration. Concentration is the ratio of the quantity of solute to the quantity of solvent, or the quantity of solution. Usually in these calculations it's going to be to the quantity of solution, much more than the quantity of the solvent. In general, we talk about concentration two ways. There's molar concentration, using the mole constant from the last unit, and there's percent concentration. The first thing I'd like to talk about is the molar concentration. Molar concentration. Molar concentration, sometimes it's called molarity, is the amount in moles of a solute dissolved in 1 liter of solution. So molar concentration, always in units of moles per liter. Sometimes we give this a symbol C, is equal to the amount of solute in moles, often shorthanded N, and the volume of the solution, divided by the volume of the solution. So molar concentration equals the amount of the substance that we're dissolving in moles divided by the volume of the entire solution in liters. Got to be in moles, got to be in liters. Concentration is in moles per liters. So let's try one. Straightforward enough. Molarity example 1. A student dissolves 0.212 moles of sodium chloride to make 0.200 liters of solution. What is the molar concentration of the solution? So we start with our formula. C equals N over V. We know that N is 0.212 mole. We know V is 0.200 liters. So take a calculator. 0.212 divided by 0.200, 1.06. I take a look at my significant figures. I have 3 here and I have 3 here, so my answer should have 3. My units are moles per liter. MOL is all lowercase letters. L for liter is always capitalized. Mole example, first one was pretty straightforward. Second one. A student dissolves 5.6 grams of sodium chloride to make 250 milliliters of solution. What is the molar concentration of the solution? Well, we're still going to need that same formula, C equals N over V. But now our N is not in moles, and our volume is not in liters. So let's change that. Our volume right now is 250 milliliters. I need to change this from milliliters to liters. And I know that there are 1,000 milliliters in 1 liter. So that would give me 0.250 liters. For the 5.6 grams of sodium chloride, well, I'm going to need the molar mass of sodium chloride. That's 22.99 grams per mole plus 35.45 grams per mole. .44 grams per mole. Alright. Well, if I have, so the number of moles of NaCl is going to be 5.6 grams NaCl times 58.44 grams in 1 mole equals, so I'm going to do 5.6 divided by the answer that I just had in the calculator, 0.09582 mole. So now that I've done this, I can put these numbers into my new molar concentration calculation formula. N is my number of moles, 0.0952. Sorry about that. 582. Let me say that again, 0.09582. And I'm going to divide that. And my volume, 0.250 liters. So since I still have this number on the calculator, all I need to do is hit divided by 0.25, 0.3832991 mole per liter. Two significant digits, I guess you could argue about the 3. Either way, this answer should be to 2, 0.38 moles per liter. So molarity is fairly straightforward. Not too bad at all. It all comes down to making sure that the amount of the solute, what you're dissolving, is in moles, and that the volume of your solution is always in liters. All right. If we go back to the beginning, so concentration in molar concentration, not too bad. Let's talk about percent concentration next. All right. There are 3 different ways of talking about percent concentration. The first way I'm going to tell you is the mass volume concentration. Percent mass volume is given as the mass of the solute, it's got to be in grams. These calculations are all about units, divided by the volume of the solution in milliliters. Solute's got to be in grams, volume of the solution's got to be in milliliters, where it's a percent, so you're going to times by 100%, just like you would if you were trying to calculate your mark on a quiz. Let's try an example. Normal saline solution is often given as an intravenous drip if you've gone to the hospital and gotten an IV in your arm, where they put a needle in and they set you up with a bag. The bag often contains normal saline. It is 0.90 mass volume of sodium chloride. Yep, and that thing was just table salt. What mass of sodium chloride would be found in a 500 milliliter bag of saline? Alright, well let's figure this out. So, if I write my formula, I know that my percent, and I like short forms, mass volume is equal to mass of solute over mass, volume solution times by 100%. In this calculation, I have been told what my percentage is. So my percentage is a known quantity. My volume, what mass of NaCl would be found in a 500 milliliter bag of saline? Well, that bag of saline is my solution. That's my volume of solution. This is my unknown. All right, well, let's plug in numbers. I have 0.90% equals, let's just go with m for my mass, divided by 500. It's already in milliliters, and that's the unit I want, and I times by 100%. So what I'm going to do is I'm going to move the 100 onto this side so I can get rid of it. I'm trying to get mass by itself. So 0.9 divided by 100. 0.009 equals m over 500. If I want m by itself, I have to multiply both sides by 500. So it's going to be 0.009 times 500 equals m times 0.009, 4.5. So wait, how do I know what my units are? Well, if the volume of the solution was in milliliters, then my mass of my solute must be in grams. So my final answer to 2 significant digits is 4.5 grams. So the mass of NaCl that would be found in a 500 milliliter bag of saline is 4.5 grams. So percent volume and percent mass work very similarly. Some solutions are not solutions where you have a solid dissolving in a liquid. Some solutions you have a liquid dissolving in another liquid. For those, if you're going to calculate the percent concentration, you're going to use percent volume. If you happen to have 2 solids that are dissolving within one another, or if you have one solid dissolving in another solid, you have percent mass. This one can be used for liquids as well, because we can measure the mass of a liquid using a balance, just like we could measure the mass of a solid using a balance. But the calculation remains the same. It's the volume of the solute in milliliters divided by the volume of the solution in milliliters times 100 for percent volume. If we're talking about percent mass, then we want the mass of the solute divided by the mass of solution times by 100. In these two cases, it's not so important that both of these are milliliters versus liters versus any other unit. As long as these are both units of volume and these both have the same unit of volume, then this calculation will work. Similarly, if this mass is in kilograms and this mass is in kilograms, there's no need to change it. As long as they both agree, that's fine. Let's give it a try.